Yeah, hello. This is just a really quick video to talk about this Samsung drain heater. There's a heater in the bottom of the fridge on the right hand side in the refrigerator compartment, and when that fails, your either the fridge will stop working properly, it will get iced up at the bottom, and or perhaps your drinks dispenser will stop dispensing drinks because the ice encroaches to the outside and freezes the pipes that supply the little cooling reservoir in the bottom of the fridge. Okay, so the following video is the work I did on the fridge, so you can have a look and see what's failed, and then tacked on at the end of that is the actual repair of the element. So it's a zero cost repair. So if you want to be able to know.
So I'm in the garage, it's November. Look, trees are just turning, wind blowing, leaves everywhere. Look at the leaves that are blown down here. So this fridge has been out here for 4 or 5 weeks now. Interesting enough, the door was open, but all the little bits of food that have been splashed on have actually gone mouldy from the warmth. Nothing's got in here, it's just stuff that was on there has been picked up by the mould and then digested. But yeah, so the back panel that I've taken out is over there, down there, you can see it. That's the bit in the back of the fridge, a lot of screws come out. But the main part of interest is down here. So here's the heat exchanging element. This is where the cold refrigeration gas comes through here, and the pipe is the actual one at the back, this one coming down here round the back. This front piece here that zigzags out of the front serpentine bit is the heating element for defrosting this ices up. What happens when this ices up is that after 3 or 4 days after a defrost, it'll work, and then the fridge temperature will start creeping up because air can't get around because it turns to a solid block of ice. Okay, now I had that problem before. Now the latest problem I had was the first signs of trouble that I experienced was that this serpentine water cooler, this water pipe goes through a small, maybe a litre or something of water in there, kept cold in the fridge. It's mounted on the front at the bottom, front bottom, haha. And then it comes out the drinks dispenser up there on the fridge. Okay, so yeah, the first thing you notice is that you go to get some cold water from your fridge and nothing comes out. You hear the bonk but no fluid, and the reason that no fluid comes out is that this is the heater I just repaired in the base here, and the condensate drops down onto here and then runs out there, but it does get frosted up. So this is where that 16 watt heater is, underneath that plate, and it's plugged in by these wires. Those wires you'll see in a moment on the bench. So I've stuck it back in with some of the 3M this is insulation tape for PIR board. It's very good, it's very sticky, it's temperature, it's waterproof, it won't peel off in the cold. But the first thing I notice is that this ice builds up from here upwards because this heater is no longer working, and it eventually encroaches on here, and these pipes freeze up just down here. You can see I put some extra insulation on in the hope that it would make it work, but it didn't. So these pipes freeze up, so you get a block of ice here, then suddenly these get frosted up and there's a frozen water, and so you get no cold water from your drinks dispenser. So if the fridge is playing up funny and the drinks dispenser is not working, have a look down here, and these are frozen. It's more than likely this heating element in the base, this one that I had out on the bench, that's gone wrong. So I'll just put it back together now, but I thought you might find that interesting because there was the first signs of trouble were no drinks on drinks dispenser because these pipes were iced up due to the fact of a big block of ice in here. But when you come to take this cover off, this cover sits in front of the of that heat exchanger is basically there, but when you come to take it off, there's a screws at the top corner here, and a screw there, and screws down there as well, but it won't come off because it's a solid block of ice and it's frozen on, and if you try and pull it off you're going to damage something, so you've got to let it defrost. I sort of wedged it forward slightly and put a heater in and defrost it that way, but you've got to let it defrost. If you try and pull it off when it's all frozen together, you'll end up pulling that off and you'll end up trouble. The fridge will be scrapped then essentially. But I'm hoping that this will do somebody. I don't need it now, but it'll do someone who wants to have a nice big American fridge freezer. It's very well made, it works well, it just needs a damn good clean now. So anyway. Right, Samsung American style fridge freezer. in the right hand side of the refrigeration compartment they have a obviously a heat exchanger, which the air is blown around the heat exchanger and cools the air in the fridge. It's like blast chills the heat exchanger, but ice builds up, so periodically heaters turn on, and there's two heaters in that side of the fridge, the right hand side of the fridge. It's a 2004 Samsung American fridge freezer with water dispenser, and I've done other videos on it, but it's gone wrong again. And what I discovered was that there's two heaters on that side. One of them actually defrosts the actual heat exchanger coil element. It looks a bit like a radiator heat exchanger. It's a coiled aluminium pipe with fins on it, and frost builds up. And if the heater on that's clamped to the front of that, it's a serpentine zigzag metal tubular heater. If that goes, then the most of the element will just ice up. And it started playing up again, and the symptoms you get is that after a while the fridge stops cooling down because there's no air circulating around the heat exchanger element in the refrigerator side, not the freezer side, the refrigerator side, right? So anyway, there's two heaters in there, and I've changed the serpentine one on the heat exchanger before, but this time when I tried to get it apart, I couldn't get the front off because the whole lot was blocked up with ice, and the front cover that comes off, that covers up the gubbins at the back of the fridge. I'm talking about accessing through the open door of the fridge into the back of the fridge now at the moment, was completely frozen on, so I had to wait a few days for it to defrost. And this is what I got out. It's a metal plate. There's bits of, I shall put some fresh, I've got some ducts, some air conditioning duct aluminium tape which will replace all this stuff. But all it is really is a piece of this heating wire, and it's kind of a stiff silicone wire, and all it's done is it's just wrapped around the back of the unit, okay, and it should be about 2 kilo ohms, and this one is reading about 2 mega ohms. I've checked it with my meter, and yeah, it's reading 2 mega ohms. Anyway, so what I did was I thought, well, as long as I remember where I puncture this, I can seal it again, because obviously it has to be watertight. And so I got my scalpel. Where is it? There's my scalpel. Got one of the number 10 blade scalpels, look, and I just pull the blade out like that, and this slots in there and stays there. And with the meter on continuity, if I can just do this whilst, it's just a handy way, because then you can use the blade of the scalpel to make a tiny puncture which will almost be self-healing in the insulation, okay. So that stays put like that, and the meter's beeping at me. Must do a review of this meter sometime, because it's a new meter and I've got a few gripes with it, to be honest. I'm not enjoying using it that much. The display is better, but you guys can't see it at all because it's not, I think it's polarized, is it? You can just see that, can't you, on the bright lights. It looks good for me, but for your contrast is not good. But you can just about see it. I'll try moving these lights out slightly. There you go, so you can just about see it. Anyway, so what I did was I stuffed, it's got a 2-pin 2-pole connector on it. I stuffed one meter lead up the wire, and then firstly I probed up here in this part. Here's a little loop of wire sticking out for some reason, and I just stuck my scalpel blade in there to make contact with the wire, and you can see that's my skin. It's 1.976 kilo ohms, right? So that's about right, half what it should be. So that meant that the section of element going from this brown wire all the way through to here, so the brown wire goes in on this side through this wire here up to there, so that part must be intact, okay, and so it must be the fault, the open circuit must be in the second half of this cable. So I then came down to where it just comes out of the unit here, and there's continuity there, but there was no continuity inside this crimped sealed unit here. The wire comes in, it goes into a crimp and onto the mains wire, which goes into the mains, okay. So the break was somewhere between this point here and here, and it turns out that I'll just go into macro zoom and I'll just show you this because you can repair this for free rather than paying £24–25 for a spare unit, okay? So let me just go into macro. So there's the actual crimp that's inside of here is that crimp, and this is the one that's failed, okay? And it doesn't look corroded, it's obviously stayed very dry, and I stress again, if I'm going to repair this, I'm going to have to make sure I put it back in a tube and seal it with silicone or something, and put some silicone on the places where I've punctured the insulation. But if I just bring this wire over to you, this is the end of this part was connected to there, okay, so I've got to make up the difference in length because I've had to cut a small section of it out. But if you look at the heating stuff, it's interesting. It's got the sleeving and the insulation, and then you've got this glass ceramic mesh, or not mesh, wick type stuff, very fine, looks almost like glass fibres to give it strength. Looks like similar stuff you get in carbon fibre cable. And then this is the actual heating element, is this little pubic hair sticking out. Can you see that? I get a piece of white paper, you might be able to see it better. All shall be revealed. Where are we? There we are. There, you can see it now, look. It's that little clock, that little watch spring. That is the heating element. And the problem is that's crimped into there, inside all the fluffy fiberglass, and it doesn't necessarily reliably make contact. So all that's wrong with this is the crimp at the very end, the last inch of cable, okay? So I've made 3 puncture holes, which I can patch up. So I've got to work out a method of latching onto this, which is a bit more reliable than we had before. And what I'm going to do is just get a piece of copper wire. Basically, this is just a leg off a component which I snipped off, and I'm going to make it into a point here. Into a point here, look. Sorry if it's out of focus, it is a bit tricky this. Cut it at an oblique angle, so we have a point on the end, you can see that. And then I'm going to stuff that down in there. Bit of stuffing. We've just lost the rugby, so I'm not happy. Oh, bugger it, I thought I'll go and fix the fridge instead. Right, so I'm going to go down into there. Try and get it in, she cried. And then give it a little bit of a push. Bear in mind, we don't want to break the wire inside. Push it in so it's sort of in there. And then I'm going to wind this around the copper wire. I don't suppose it gets very hot, do you? It's, was it? We'll measure the resistance in a moment, and we'll try and work out roughly what power this thing is, the heater I mean. Alright. So I wound it around, make a contact. Stuff's getting in the way as usual. I'll try and pull it out of the way. Can't really see very well because I'm trying to keep my head out of your field of vision there. So I give it a bit of wind and then solder it, I think. Just going to put some solder on it. Flux her up a bit, some flux on it. Can you see that? Can you see the rust coming off this? I'm going to put a bit of paint on there as well. See if we can get this to focus, shall we? Stick that underneath it, should get something for the focus algorithm to get its teeth into. Yeah, look at that. Know your camera, boys. Not even sure that's soldering here. It might be some sort of nichrome or something like that that won't solder. We'll see. That's soldered right. Okay, so I've soldered it on. So I've made a good electrical connection. Now we've got to support that mechanically. So what I'm going to do is put some heat shrink over there. And what I've got is some heat shrink which has got glue up the middle. If you've never seen adhesive lined heat shrink, then I recommend you get yourself some, because it's phenomenal stuff. This isn't it actually, because my heat shrink is at the office. That's the phone ringing. I'm back in a second. Yeah, that was a customer. So anyway, I've got some thin sleeving to go in as the first level of protection. So I'm just going to slide some thin sleeving over the top. Put my hot air gun on. And there's another layer of protective sleeving over the top of that. If it'll go, it will. In fact, it won't go over there, so I might need another piece to go over the main part of the. A bit difficult focusing on that, isn't it? Put that on there. If I put that back there, we'll get something to focus on. There you go. So and now I'm just going to put another piece of sleeving over the top, belt and braces, and I'll probably wipe this down with some silicone sealer before I put it back in. But that saved me 25 quid, because it was just a bad crimp that caused that. It wasn't the wire that had burnt out. It's very low power going through the unit, and it's never been moved or used, so it's not going to have any sort of like stress fatigue failures or anything like that. It's purely may have been faulty for some time. But the main thing to remember is there's two heaters in that side. The main one is a serpentine metal heater clamped to the front of the heat exchanger, and the second one is the one that's in the bottom tray, the drain. This is where the condensation drops down out through the hole in the middle, and runs out the back of the fridge and then evaporates out the back of the fridge. But if this heater blows, then the ice builds up on the inside of the fridge, builds up, and then at the base you end up with all this stuff coming up. It's not very good, right? So if we just check with the meter, I'll just check it now, and you can see what impedance you're supposed to have, or should I say resistance in this case. Impedance is a complex quantity which is frequency dependent usually. Of course at DC the impedance is the resistance. So now we've got 2.174 kilo ohms, so it should be about 2 kilo ohms, that heating element. Now I'm going to put this back together, recrimp that back onto there, and then put some more solder and put some tie wraps around it. But you can get the gist of it, that basically you can repair this heater rather than buy a new one, because it's likely that the bad connection is up here near the output. But clearly when you've repaired it, you're going to have to put some silicone around it and some self-amalgamating tape to protect it from the moisture in the fridge, because otherwise you might get some electrolytic action with some condensation causing it to fail. So that's the repair of the heater. I'm just going to crimp that back in there, which I can do. I'll get some sleeving on it first. Yeah, what they've done is they've mashed this stuff through. See that? That's the crimp. Let's slice that piece off. Slice that piece off. And then whatever you've got to do, you've got to avoid pulling on that wire, so put some positive pressure on it, pushing it into that direction, and then we're just going to crimp this down again onto the wire. Okay, so that's now crimped. Now the name of the game is going to be to bind this up in some self-amalgamating tape, and then we're done. So here she is. I've put some silicone inside there, and then put some of this 3M insulation. It's gap insulation tape. It's insulating gaps in the foam PIR insulation, but it's very, very sticky.
it's waterproof, and it's aluminium. So I've just coated the rest of it to repair the patched holes in here, and put some around there. And then this is this stuff, which is self-amalgamating tape. It's like a rubber polyurethane tape, and as you wind it up, it binds to itself and makes a rubber boot. So if you're doing 2 wires like that, then wrap some around both wires so they're individually wrapped, then push them together to make a seal, and then wrap round them both with an outer layer, and that will seal those wires so no water can get into our new connection, which is now encased in there. Okay, so I'm going to put this back, so it's a zero cost virtually repair, and the fridge is getting towards the end of its life, but this will keep it going along without having to spend any money on it. It doesn't take long to change, so if you can, just subscribe to our little button down in the corner. We appreciate it. And if you've got the same problem, I sincerely hope that this is useful information and may allow your fridge to carry on trucking. So take care. Goodbye.